You know, if I had £1 for every time I said welcome back on this course, I'd probably have a few quid now, maybe enough for the price of a decent beer or something. I don't know. How much is beer? I don't buy much beer. I get it given. Or maybe not. I digress. Welcome back. You came back. Thank you so much. If you didn't come back, I still don't care. I have no way of knowing. But today we are going to have some fun. If you're wondering where the fun in your life has gone, then it might be here. Can't guarantee it. Might be here. We are going to do some quite neat stuff with XNA though. We're going to draw some pictures. We're going to start using resources. We're going to start actually getting images into our program and doing stuff with them. And the nice thing about this is that the images can be from anywhere. So if you've got pictures on your camera you want to actually put into your games, this will tell you how to do it. So stick around. Loading and displaying images in an XNA game program. Let's go to it now. We've been around the block a few times. We've actually learned that we can create game programs which take input from the gamepad and even display text. And we know how to get fonts to display our text and put them on the screen in certain positions. Next thing I want to do is move up the media scale a bit from words into pictures. So we're going to look at how you can load and display images. And the good news is that actually if you're okay with text, then pictures are not going to be that much of a problem. You're going to find that a lot of things are very similar because the designers of XNA have been really rather clever in terms of how they've actually put this whole thing together. So our story so far we've done. We're going to find out how to put images and audio into XNA games. Later on it's audio. This time it's images, so next time we're going to put music in, and at that point you've really got a lot of power. The process is similar for any other kind of media you want to add. If you're a 3D games programmer, you'll be designing models, buildings, tanks, players, etc., and those will all be brought into your game as content, just like everything else, because as far as the game is concerned, it manages all the stuff that isn't program in terms of this content stuff. If you take a look at a fairly advanced game, here's one called My Space War Win 1, which has got audio, fonts, models, shaders and textures, and there's lots and lots and lots of these files in different formats, and we've added fonts. The person that made this rather cleverly put the things into separate folders so they can tell them apart. We've made fonts in the past. We're going to have a look at doing some pictures, or as the proper posh games programmers call these things, textures. Okay, so putting these things in just the same. The process by which you do it is managed for you by the XNA Content Manager, and we're going to be looking at 3 different types of image. JPEG or JPG, which is a very good type for images which form the background of your game, skies, landscapes a long way away, all that kind of stuff. There's a format called GIF, which you may come across, which is very good for little images, little sprites and things. And there's another format called PNG, which is called Portable Network Graphics, and that's good for images that have transparent bits that you want to actually see through. Which one you pick really depends on what you want to do with it. The thing about the JPEG type picture is it doesn't support any kind of transparency at all. You see, the way that XNA draws things that aren't square is that it makes some of the dots in those pictures transparent, so you could draw a ball as a square texture and it would look like a ball because all the bits around it will be transparent. You see, that's how they do it. That's how all games work. Okay, fine and dandy, works a treat. Problem is you have to have a graphics format that'll handle the fact that some of the pixels might be transparent, some of the dots in the picture might not appear on the screen. JPEG can't do that. GIF can't do that, although there are ways around that. PNG is good for actually that kind of thing. So pick the picture that suits the problem. We'll be doing a bit more about how pictures work a little bit later. But for now, if you have some pictures from your camera that you want to put in a game and they're in JPEG, that's absolutely fine. It'll work a treat, no problem. But if you want to do round ones or funny shapes or spaceships that have particular raggedy edges, then you have to go up to using PNG. And using programs that will handle transparency, of which more a little bit later. But before we're going to do that, Really bad news, actually. Very, very sad to say that Jake, the good-looking dog in the picture you see before you, has passed away. Poor old Jake. He had a great life. He was a fantastic dog, and had a really good time. But early this year, I'm afraid that he became no longer with us, and so I wanted to live on in picture form because he was truly the best dog I have ever met. And this is a picture of Jake in his prime, and Jake is a JPEG picture, and I want to put the picture of Jake in my game. Okay, that's where we're coming from with this, and so I took some pictures of Jake when he came to see us, and one of them I've been using in these kind of presentations and bits and bobs ever since. Great dog, fantastic hound. Here he is. Okay, so we're going to display him in our program. That's how it's going to work. Okay, as far as we're concerned, adding Jake to a game is just like adding a new font. Last time we did this, we made the font. We told XNA, I want the font to be a particular typeface, that's design of characters, and a particular size, that's the number of pixels, the size of the actual text it's going to draw. In the case of Jake, we just go off and we fetch ourselves a reference to the file that contains the picture. And the file is called jake.jpg. It's in the content folder, which is nice, and it even has a little picture icon which you can see there, which tells us all what Jake actually stands for. So absolutely fine. Drop that in as a lump of content, and at that point we can pretty much forget about it. XNA will take on the job of picking up the picture, making it into a form suitable for use on the target device, and then moving it across. The content manager is great. It just does all this. The way it works is that every single type of data, whether it's an audio file, a JPEG picture, a PNG picture, or a model or whatever, has a particular type, a bit like you have Word documents and spreadsheets and PowerPoint presentations. All these files have a characteristic type, and the content manager has an importer and a processor for each of those types. And so it has one for JPEG, it has one for PNG. It grabs these files, it does whatever it needs to do to get them into the game, and it makes them available for use within the game as well. So as far as we're concerned, it's a no-brainer. We don't have to think. We just ask the content manager, hey, go off and fetch that picture from a resource called Jake, please, and the content manager will do just that. Now, when it fetches the thing you want to draw, it has to actually put it somewhere. Now, we've been using types in our programs for, well, forever really. We had the byte type for holding small numbers, we've had integers, we've had floating points. We even had a type called sprite font that would contain an entire font. Another type to look at called texture 2D. It's a two-dimensional texture, a flat texture like the page of a book, or a slide, or something, or a picture on a piece of paper. Texture 2Ds are specifically for holding these things. You can have as many as you like in a game. Some games have many hundred different textures. We declare a variable of this type, same old routine. It's in the game data area. I've called it Jake texture because it's going to hold the texture which describes the picture which has got Jake on it. And once I've declared it, next thing I have to do is actually load it. And the LoadContent method, this magical method that runs when the game starts going, is the place to put jobs like this. So content has a load method. We saw this when we were loading fonts. This time we're saying, please would you fetch me a 2D texture and fetch it from the resource called Jake. So Jake texture gets given the result of this load call, which is the texture in the resource called Jake. Of course, if we get that wrong, if we ask for Juke or Jike or Joke, then the system will go, hang on, can't find that, and tip over. And of course it'll do that when the game runs, because the thing that's converting your program into the instructions for the computer has no way of knowing what resources you've got. So as far as we're concerned, the compiler will go, oh, that's fine, that's wonderful, that's super, terrific, I'll run that. And then of course when the program runs, it'll go, hang on, not got a resource with that name. So as far as we're concerned, only thing is make the name here match the name you gave it when you brought it in, and everything in the garden will turn out lovely. Okay, so we have our texture. Next thing I want to do is draw it. I'm going to say I'd like to draw the texture. I'm going to position it at the top left hand corner of the screen, and a vector which points nowhere will cause the system to do this. Remember when we were placing text on the screen, we used a vector to do this, and we found out that the top left hand corner of the screen up there is 0, 0, and then as we actually move down here, x gets bigger and y gets bigger. So if I put a vector at the top of the screen, it'll be up there, and I'm drawing the picture with white light. So I should get a picture of Jake appear on the screen before my very eyes. Now, talking about this is one thing, doing it is something else. Let's do it. Let's go. So I'll get rid of you. I'll go up here and I'll fetch my program and I'll open it up. This is exactly what I've told you. Nothing new, nothing magical. So if I open up the game 1 file, take a look in the content folder. Hello, there's my picture of Jake. Drift down to the load content method, and there it is, fetching a texture called Jake and putting it into a variable called Jake texture, and then down here in the draw method, draw it top left hand corner, color of white. So I'm going to press the go button and see what happens. There'll be a rattling noise, dum 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 dum, and there it is. Lovely picture, fantastic dog. Right, so stop the program and the picture goes away. We can have fun with this. It isn't in the script, but I'll have a go anyway. One of the things you can do is you can change the color of the light that shines on the picture. Watch what happens if I change the light to blue. So I can type blue, which is not guaranteed. Right, run the program again now. Now I'm drawing the picture with blue. Ooh, there's a blue Jake. Now, if you've ever wondered how programs make images fade in and fade out and that kind of thing, I think you're probably starting to see that now, because we had some stuff with mood lights where we were playing with colors and filling the screen with different colors. One of the great things about XNA is you can actually use this technology, you can use this color drawing thing to actually draw pictures in different colors. So I can make, if by drawing with successively brighter colors, I can make pictures appear darker or brighter. I can make them have particular colors, like in this case blue, and so on and so on. So you do, just with the simple drawing method, have a very large amount of control over what you can do. So that was drawing Jake. Fetch Jake and draw him. I could try different colors, but I'd rather get back to the slides just right now if you don't mind. So let's keep going forwards. You've seen Jake. We turned him blue, but we did draw him in the natural color to start with, so we know it works. Now, the reason why this all kind of worked okay is that I'd previously made the Jake.jpg file a sensible size. In this case it was 600 dots wide and 450 dots higher. Now the actual size of the screen that XNA gives me is 800 dots by 600, so the picture of Jake just fits nicely into the top left hand corner, as you can see here. So it doesn't go all the way across and doesn't go all the way down. If I got an absolutely enormous picture of Jake, then using the present draw method, it would just fill the screen and fall off the edge. The technical term for this is clipping, which is where XNA just draws what it can see and the rest of it's ignored. Now, previously, when we've messed around with computers and tried to push things in that were too big, the computers kicked back by actually going wrong and giving us overflow and errors and stuff. In this case, XNA does not care. You get away with it this time. One of the few free shots you ever get in this business. XNA just draws the bit that fits and leaves the rest off the screen. Okay, XNA is perfectly happy to do this, and it will also do image scaling if you want. It'll take an image and make it fit on whatever size destination that you want. Before we go into precisely how this works, though, probably worth mentioning pixels. A pixel is a dot on the screen. People go on about these things. My camera is a 10 megapixel camera. Well, big whoop. What does that mean? It means that the picture is made up of 10 million little dots, arranged with so many thousand down the screen and so many thousand across. Now, bearing in mind that XNA is giving us 800 dots by 600 dots, that means that if you do show a picture that you took with your camera, it'll probably look a lot like that, because this is 800 wide, 600 high, and this is the dog picture is thousands wide and thousands high. So this scaling thing sounds like it makes quite a lot of sense. And as far as XNA is concerned, the units we're going to use to place things on the screen is the pixel, and a pixel is the size of a dot on the screen, as you might expect. So that's easy enough. To do this, another XNA type just came to the door. Hello, jolly good. How good weather? Yeah, fine. This is the rectangle type. Actually, a type did not come through the door. That was a piece of dramatic license. Actually, I haven't paid my dramatic license this week. Can you tell? Anyway, I digress. The rectangle is an XNA type which actually defines a particular area of the screen. We use 4 numbers basically: the X and Y coordinate of the top left hand corner of the rectangle, how far down the screen it is and how far across the screen it is, and the width of the rectangle and the height of the rectangle. Okay, so by setting up one of these beasts, we can basically tell the XNA draw procedure, hey, put it in this rectangle please, and it will do that for us. The rectangle of course becomes part of the game data, so my game data has now 2 things in it: the actual rectangle I want to draw, the texture I want to draw, and the rectangle that says where it's going to get put. And what you can do is you can use the update method to actually change the rectangle's draw position, and that's quite a good way of making things appear to move around the screen, and you will be doing that session after next, I do believe. So let's look at a new load content method where we go off and fetch our texture, and then we make a rectangle value for Jake rectangle, which is 100 pixels across the screen, 50 pixels down the screen, 200 pixels wide and 100 pixels high. And when we draw, we use a different form of the draw method in Sprite Batch to say draw me a texture, put it in a rectangle I've just told you about, and use white light. So now we're telling the draw method this is where we want the picture to be positioned, please, and it all just comes out in the wash. Lovely stuff. Let's have a look at widescreen Jake. Let's go back to the desktop. Bink. Go off and get my second demo and open it up and take a little looky look, and down here there's my rectangle. Okay, and then moving further down, here you go, 100 pixels across, 50 pixels down, because remember the top left hand corner is 0, 0, which is confusing, but it's how these things work, I'm afraid. 200 wide, 100 high. Run the program, see what happens. What could possibly go wrong? Nothing. We have a long, thin, stretched Jake, and he's about 100 pixels. Well, he's exactly where we told him to be. He's 100 across and 50 down, and he's 200 wide and 100 wide. And if you don't believe me, and why should you, I can make him square by changing the height to 100 and running it again. And now we have a square Jake. Or I could make him long and thin. Let's make long. I quite like long and thin, so we'll make him 400 high, and we'll squash him. Some of these there you go. He's all squashed now. Some of these pictures might remind you of what happens if you get your telly. You're watching the wrong kind of widescreen thing, and people seem short and fat, or long and thin and scrunched. This is exactly what's happening here. Pictures have this thing called an aspect ratio, which is the actual width to height ratio type thing, and if your program changes this, it'll make the pictures look a bit weird, but I don't really mind about that too much at the moment, and it's quite interesting how tolerant the human eye is of these kind of distortions. But anyway, to get back to the plot, we made a rectangle and we used that to control whereabouts on the screen and the size the picture has when we draw it. So wonderful. Worth a round of applause, but if you want to clap, that's fine. I can't hear anyway. Okay, so one of the things that we do have to deal with though when writing XNA games, this is kind of important, is that if you ever use an Xbox, you'll find there's different configurations you can make for the screen. You can have widescreen or whatever. That's kind of worrying as this thing stopped. And no, we're still I'm getting paranoid about my screen recorder because sometimes it stops and I never know why, and I might have stopped it now, but I don't think so. I think it's still going. So if you're not hearing this, it means the recording has failed. Okay, to get back to the plot, Some devices have different screen sizes depending on the monitor and the television. The XNA lets you pick between different types of HD and all kinds of stuff. Games need to handle this automatically. They have to magically figure out how big the screen is and scale things accordingly. And it turns out this is quite easy to do. Because the graphics device, which is the thing driving the screen, has a viewport member which exposes a width property which tells you how many pixels wide the screen is, and it also has a height property which does the same thing but for the height. So I can use these two numbers to make a rectangle which actually fits the screen perfectly. Okay, so what happens now if I let's say, I get too excited. I'm getting ahead of myself. Next demonstration is full screen Jake, where I do just this. So let's do just this. I'm going to move on to there and do that. And now I'm going to go into my final demonstration and start it running. And bring up the game. Bring up the game! And in here, if we drift down to the bottom, there you go. I'm saying get me the width of the screen and the height of the screen. And if I run this, the picture of Jake will perfectly fill the screen. So my games can actually work out from the information they've got how big they have to be to fit the screen. In other words, they ask, it's a bit like arriving somewhere and saying, where's the bar? First question I ask. Although I'm not a big beer drinker, established this already. This thing, the program makes up and goes, okay, how big is the screen? How wide is it? How big? How deep is it? And then it makes the image fit the required thing. And the program will scale this automatically. It'll scale your image automatically. If it needs to make the picture bigger because you're drawing a small picture in a big area, it'll do that. But of course it'll look a bit blurry. It'll actually scale it, but it won't look as nice as it might do. And again, if you've watched TV, you'll have seen small pictures being scaled up and getting blurry. In CSI, they stay sharp all the way in because they lie about how good cameras are, but in real life, make small pictures bigger, they do get blurry. So what we know so far, images come in as any other resource. We can bring in different types of file formats, and we use this rectangle mechanism to actually place them on the screen. And if you want to find out how big the screen is, use the viewport to tell you that. All works a treat. So that's what we know, true and false. Okay, pictures are managed by the content manager. I'll give that a thumbs up, ding ding, because that's true. The screen is 1 pixel in width. No, that's a light bulb. A light bulb is 1 pixel in width. The screen is 800 or 1000 or however big you set it to. So that's going to be rubbish. Only the update method can load pictures. Oh, Robert. No. LoadContent loads pictures. Update will do things with pictures next time. All pictures must be held in the PIX format. Never heard of the PIX format. Probably doesn't exist, therefore that's probably wrong. The rectangle type holds the picture to be drawn on the screen. That's a good question. If you know the answer to this one, then you really have been paying attention and you deserve a prize. I have no prizes and I can't tell if you're agreeing or not, but the answer is that the rectangle type does not hold the picture. It just says where to draw it, so that's going to be false. So 1 true and a whole bunch of falses. 4 falses. Ooh, how terrible. Okay, moving on. Because we can use this ability to actually move the rectangle around the screen and XNA just flips when it has to, we could make a program that lets us zoom into images. We load the image in and then we press buttons to change the draw position and the width and the height of the image. Might be fun to do that, and your boss has decided to make a Where's Wally type game where you can zoom around images and try and find pictures of people. Fantastic. But the developer who's going to write it was attacked by a unicorn on the way to work and is presently hiding in the forest. At least that's what he said on the phone. Not exactly credible in my estimation, but there you go. Bottom line as far as we're concerned is we now have some program to finish. So there's a lab attached to this piece of work which involves bringing in images, doing things with them, and moving the picture, draw positions and things around with the gamepad. So feel free to have a go at that, as usual. A classy fade at the end to the screencasts part of Very Silly Games. That's where you can find the bits and bobs. That's where I hope you'll go next. Well, thank you for paying attention. If you've been asleep all the way through and only woke up when I mentioned beer, then fine, stick with it. I don't care. I'll be here next time. Until then, bye bye.